Welcome, everyone, and thank you for joining us for today's webinar, How to Rethink Cyber Risk in AI, a fireside chat with JupiterOne. My name is Amanda, and I'm part of the virtual events team here at Neo4j. I'm thrilled to be joined by Tonkin, Chief Product Officer at JupiterOne, an AI risk management platform that helps security teams in highly regulated industries understand and prioritize risk across complex AI-driven environments. Joining us as well is Bryan Nairn, Vice President of Product Marketing here at Neo4j. Today's conversation will explore how organizations are rethinking cyber risk in AI by connecting their data to uncover hidden risks, accelerate AI-driven insights, and make faster, more informed decisions. Before we get started, just a quick note about questions. We invite you to submit any questions you have throughout the session using the Questions tab located at the top of your screen. And so with that, I'll go ahead and hand it over to Bryan and Kevin to get us started.
Hey, thank you so much. And Kevin, it's thanks for joining me. I'm really excited to chat with you. Having spent the earlier portion of my career in network security, intrusion detection, content filtering, I jumped at the chance to be able to sit down and talk with you. And so maybe we could start out with something that is pertinent in today's age of AI. We are, I guess, now almost 6 weeks past Anthropic's announcement of Project Glasswing. And for those of us joining today, Project Glasswing surfaces O-Day vulns across major operating systems, which was a focus of my life at one time working in Microsoft's trustworthy computing. And so I would love to hear, what was your reaction when you saw the announcement and just your general thoughts?
Yeah, thanks for the invite. It's great to be talking today. So yeah, honestly, my first reaction, I think, was that it was a watershed moment. Not a surprise, I guess, in that we knew it was coming, but certainly jarring in the sense that it's not here. For years, security teams have been playing this reactive game where vulnerabilities get discovered, researchers report them, patches get issued. But what Glasswing really is represented is AI collapsing that timeline very dramatically. So being able to find things at scale and speed that no human teams could replicate. So for me, sitting where I sit, I think it cuts two ways. On the one hand, it's really validating everything that we've been building towards. So the idea that connected, structured data about your environment is the foundation for any AI capabilities that actually matter in security. You can't really act on what Glasswing finds if you don't know which of those vulnerable systems you own, where they are, who has access to them, and whether they're exposed to the internet. And that's really the exact problem that JupiterOne was built to solve. And then on the other hand, I think it's really a clear signal that the adversaries have access to the same tool. So the urgency around having that core foundation in place for defenders is really going from being a nice to have to at this point really being table stakes. So really that was my initial reaction when I saw the news coming out of Anthropic a few weeks ago.
Yeah, I'm a little apprehensive, I suppose. I've always been a supporter of coordinated vulnerability disclosure and being able to have at least mitigations in place, even if there wasn't a patch available. So thinking about all those O-days and thinking about the risk for organizations is, it feels a little overwhelming to me. But, you mentioned something about what JupiterOne, like the problem that you were created to solve. And so for the folks that aren't familiar with JupiterOne, maybe you could give us a quick picture of what the platform does and elaborate on the problem that it was built to solve.
Yeah, sure. So the core problem that we solve is that most modern or many modern organizations don't really have a clear picture of what they own, what's exposed, and what's actually at risk. And it's not because they lack tools. And in fact, they have too many tools. So research really has put the average enterprise security team as having 76 security products in their stable, which is a pretty crazy number. And every single one of those is generating its own data, its own alerts, its own notion of what matters. And none of them are really talking together in any meaningful way. So JupiterOne ingests all of that. So you're talking cloud infrastructure, identities, code repositories, endpoint vulnerabilities, compliance frameworks, you name it, and organizes it all as a connected graph. So not just a list of assets, but a map of how everything relates. So this EC2 instance is running the service, which is accessible from the internet, which has this IAM role, which has access to this S3 bucket, which contains personally identifiable information. So that chain of relationships is really what tells you whether something's actually a risk or just noise within your environment. So once you have that foundation, you can then start asking real questions, not just what do I own, but which production assets are accessible from the internet, haven't been patched in the last 30 days, are owned by a team that might have been downsized. And it's those kinds of queries that previously could take weeks to answer. We're now getting down to seconds. So previously you might have to be gathering data from 5, 6, 10, 76 different systems. And it was really an almost insurmountable build challenge. So getting it all into a connected graph-based environment that you can then start to reason and query over the top of is the reason for J1's existence.
So you kind of answered the next question that I was thinking about, and that was, I was curious to talk a little bit about the challenge of fragmented data and siloed tools and all these disconnected systems. I imagine that you probably talk with a lot of security teams and executives, and so obviously you're focused on this problem. So I imagine that the problem is really real, and you gave a little bit of the statistics behind that, but maybe you could talk a little bit more about that. How is this showing up in terms of business and business outcomes, and what decisions are getting made poorly or not made at all because of all of these fragmented systems and not being able to play together?
Yeah, so I think the way that I see it most commonly manifesting is, maybe I can give a couple of examples. One might be in a meeting before the board meeting where the CISO is trying to prepare slides and pulling data from lots of different locations. Or maybe even worse is kind of on a random Tuesday morning when the CEO opens up the Wall Street Journal, learns about some latest, greatest exploit that's made the news cycle, and immediately is calling the CISO asking, are we at risk? And so the CISO in that scenario is really trying to answer a question like, do we have exposure to this vulnerability that just dropped? And instead of them being able to just pull up a dashboard and know the answer, they're really on Slack pinging 5 different team owners. They're waiting on a spreadsheet from the cloud team. They cross-referencing a vulnerability scan report that's maybe a week old. And by the time they have something resembling an answer, 2-3 days have passed already. And really what's happening is underneath all of that, I believe, is a data infrastructure problem. So every tool was built to answer its own narrow question well. So your vulnerability knows a lot about CVEs. Your CSPM knows about cloud misconfigurations. Your IAM tools know about identity. But nobody has built the connective tissue between all of these tools. So you end up with a CISO who has really 12 different dashboards. And at the end of the day, no situational awareness.
You touched on a couple of things. You touched on data architecture. You touched on being able to have a complete picture. Obviously that is the problem that JupiterOne is solving. I'd love to hear a little bit about, how your own data architecture started out, and then as you grew and started adding on more customers and those customers ingesting data, but what types of breakage did you see, or what type of scaling issues did you see that showed up for JupiterOne?
Yeah, I think it's been an interesting journey for JupiterOne over the years. You mentioned as we grew and as our customers started to become bigger, we learned things about our initial architecture that required us to change. So the architecture that we built originally back in the day was actually quite clever for the time. So we had a dual storage approach where we had one system which was optimized for flat queries and another that was optimized for complex relationship traversals. And the reason we did that is that security data is deeply relational, and no single store was really handling both workflows well at our scale. And so we ended up engineering around it. And the problem with that kind of architecture was that everything seemed to compound upon itself. So every piece of data that we ingested had to be written to 2 places and kept in sync, which caused no end of issues. So you end up with this weird web of loops, synchronization jobs, duplicate stores. The operational overhead started becoming pretty large. And the surface area for things to start going wrong is constantly growing. So our engineers were spending a meaningful chunk of time really just keeping the plumbing consistent. And that time, I'm speaking as a product officer, that time could much better have gone into actually building product. And then what we saw on the business side, it was really manifesting itself in query latency and data freshness issues. So a question that honestly should have taken milliseconds then starts to take seconds, then tens of seconds. And customers over time start to implicitly learn that certain queries are just too expensive to run continuously. So they then only run them once a month. And that really erodes the core value proposition of an offering like ours, which is real-time risk awareness. So you can't market this concept of continuous visibility while only relying on these periodic snapshots. I think the data freshness issue turned out to be, one of the biggest issues for us. Over time, as our customer base grew and we started working with larger and larger enterprises, ingestion was in some cases taking up to 8 hours for larger customers. And stale asset inventory and security is arguably even worse than no inventory at all, because it gives you this false sense of confidence. You think you know what you own and what's exposed, but ultimately you don't. And then the last one, this was relevant as well, is really the problem that kind of made a decision for us to re-architect was a unit economics one. So in this dual storage architecture, your infrastructure costs scale with every new customer that you add and every new data source that you add, because everything's getting written twice, stored twice, kept in sync across two systems. As we grew, the pipeline costs really grew with us in a way that weren't sustainable. And at some point, you reach a point where the cost structure of the architecture is really in direct tension with the growth ambitions of the company. And at that point is really when it stopped being a technical conversation and became much more of a leadership conversation as to how we needed to re-architect our systems.
Thanks for that. So what I hear you saying, I'm hearing all the things, right? So I'm hearing, we want to reduce operational overhead. We want to be able to scale. We want to reduce costs. All of that totally makes sense. How does that really translate as you take on this massive task of looking for a new platform? How do you define that? How do you set the bar? What does that look like?
Yeah, so I think the bar for us was pretty simple to state, but actually remarkably hard to meet. So we needed a data layer where the cost of a query didn't scale with the complexity of the relationships being traversed. At the end of the day, that's what we were looking for. So as I mentioned earlier, security data is inherently deeply connected. So an asset connects to an identity, which connects to a policy, which connects to a risk, which connects to some compliance framework. And those chains can be, 8, 10 hops deep. And in a relational model, that's typically a series of increasingly expensive joins for each hop that you take. And in a native graph, it's really the natural query pattern. So what distinguished Neo4j for us wasn't just raw performance. That was certainly part of it, but it was really the combination of performance, operational simplicity, and developer experience. So I think when you're re-platforming a production security system, it works fast on benchmarks. It's really just table stakes, right? So that raw performance is important, but it's just the beginning. You also need a system that your team can operate confidently at scale, and also one that doesn't reintroduce the same kind of maintenance burden that we were trying to escape. And what we saw when we were looking for a system that was going to check all three of those. And then also candidly, just going back a few years, we were already at that time thinking about AI. So if you believe, as we did, that the next phase of our platform was really going to be AI-driven reasoning over security data, then ultimately the quality of the data model is what determines the quality of what the AI can actually do. So we wanted a foundation that would support where we needed to go, not just where we were at the time.
Maybe you could say a little bit more about that. I mean, I'm interested in, obviously like query performance improves, confidence improves, and I'm curious what the internal reaction is to, and then like how people feel and what they can build. But I'm really even more interested in like what you're thinking about building with AI. And you said something that, and I just came back from Gartner's London Data and Analytics Conference, and everyone was talking about the semantic layer and having more context in your data in order to make AI accurate and trustworthy. And so I'm kind of curious to sort of skip ahead and maybe hear more about what this enabled for you and how you were thinking about AI and what you're able to build now.
Yeah, I'll answer the first part of your question first around like what was the internal reaction, because I think that was interesting because honestly we had a little bit of a mix of relief and disbelief initially, right? So we had been living with constraints for long enough that I think we'd started to normalize them. So you start to build a product around what's possible, not what should be possible. So when we started first seeing some of the numbers coming in around the rearchitecture, I think the first reaction across the company was, a dose of healthy skepticism. Is this test representative of real workloads? And frankly, I think that even included some within the engineering organization. But once we validated that it was, the shift in what the team started thinking about was actually interesting, because when data ingestion takes 8 hours, your whole product philosophy is really organized around that constraint, right? So you batch things, you make trade-offs, you tell customers, oh, this updates nightly. And when it only takes minutes or in some cases seconds, you can really start to rethink everything. You can run continuous queries. You can alert in near real time. Frankly, you can just start to build features that just weren't on the table before. And then just in terms of the reaction, the other one that I thought was quite interesting is coming from outside of engineering and from customer-facing teams. And for them, I think it wasn't so much excitement about what we could build next. It was relief, honestly, pure relief, because the things that have been driving customer dissatisfaction a few years ago, so stale data, slow queries, incidents where something timed out or fell out of sync, those were all the things that were generating support cases, fire drills, and in some case churn. And when the migration landed, that noise just stopped. It was really interesting looking back at the source of incoming tickets, and support volume really plummeted around those types of issues. Customer satisfaction scores started moving in the right direction in a way they hadn't in a while. And frankly, those are the things that don't really show up in technical benchmark numbers, but it might be in many cases the most important outcome of that project. Now, you asked the question about beyond cost, speed, et cetera, what could you build once the foundation's changed and what becomes feasible that wasn't before. So one example I think of that is what we refer to as a continuous controls monitoring solution that we just launched. And it's actually a good example of why a graph matters specifically here, not just a faster database. So controls monitoring is really fundamentally, at the end of the day, a relationship problem. So does this control cover this asset? Does this policy apply to this data class? Does this access grant satisfy a requirement? And those aren't lookup questions, they're traversal questions. So you're really walking a chain of relationships to determine whether a control is effective or not. Now, graph encodes your control framework natively the same way as it can actually encode your environment. So instead of running a controls check by assembling data from 5 different systems, you're traversing a graph that already holds the environment and the control framework as connected nodes. And that's why you can start to monitor controls continuously rather than periodically. So that was a really interesting example. And then I think the one that I'm most excited for is really what it did for AI. So I mentioned earlier around how when we were looking at a new solution, we were trying to kind of look ahead for what we may be able to do on top of the data as the substrate. And at the end of the day, graph data is structurally the right data model for the AI age in a way that flat data just simply isn't. So the example I might give here is if you give AI a table of vulnerabilities, it can tell you which ones maybe have high CVSS scores. That's not intelligence, that's just sorting, right? But where AI, I think, becomes generally powerful is really where it can reason over context. So for instance, this vulnerability is on this asset, which is internet facing, which sits in this environment, which connects to this system, which controls sensitive data, right? The graph is really what's encoding all of that context natively as relationships. And then you're asking the AI to not just infer connections from flat data, you're handing it a structure that already represents the way that the AI needs to reason about the data. So really, we think of the graph as the reasoning substrate for our AI, not the data store that the AI queries, but really the structure that makes AI reasoning about security really coherent in the first place.
Got it. Yeah, makes complete sense to me. I think not just security leaders, but all leaders, I think today, when considering the AI investments, you've read the studies, depending on who you're talking to, it's 8 out of 10 AI investments don't make it from pilot to production. And ultimately that's because of hallucinations, answers that you can't really explain. There's no provenance there. So organizations don't fully trust the AI generated outputs. And you talked a little bit about trust, if not explicitly, but talking about being able to reason over context. I'm curious if you could maybe speak a little bit more about how you think about building trust into AI so that your customers feel good and feel that the AI that they're using is trustworthy.
Yeah, I think that's a really good question. Particularly as, frankly, every product out there now has an AI story, and some of those stories maybe are better in reality than others. And I think, personally, I think about trust as a function of really two things: transparency and grounding. So transparency really means that the AI has to show its work. So I can't expect a security engineer to just accept, hey, here's a critical finding from this J1 black box, right? They really need to understand what data was used, what relationships were traversed, what logic led to the conclusions that the AI reached. And if they can audit the reasoning, that ultimately they can start to calibrate their trust over time. So I think that's really paramount is transparency and finding ways to, as you reach conclusions, very easily give users the ability to kind of query and question into how you reach those conclusions. So transparency, the first. Grounding, I think, is the more fundamental thing. So I think that in many reasons in many cases, the reasons that AI in security maybe fails to land as well as it could is that it's generating outputs from maybe imprecise data. So if your asset inventory is incomplete, for example, if your access model doesn't reflect reality, if your data are 2 to 3 days stale, the AI output is only as good as the reasoning, only as good as what it's actually reasoning over. So, the answer to how do you build trust in AI, I think, is in large part fix your data. So really what we're doing with J1 is trying to ground every AI recommendation in the actual graph state of a customer's environment. And when J1 says this is a critical risk, it's pointing to real nodes, real edges, real data. You can click through to the underlying assets. You can look at the underlying findings. You're not asked to just trust a score. You give them the evidence and the path to remediation, so you can then make your own, assessment of the efficacy of the system. And that then allows you over time, I used the word calibration earlier, you can really calibrate over time. Yeah, if this system has been showing me correct data that's validated by myself as an expert within the field, and it's been doing that consistently over weeks, I will start to trust that a lot more. But I think visibility and transparency and grounding are the two critical pieces here.
Got it. One of the things that you talked about that I love is just sort of being able to provide a technology that democratizes intelligence. So you don't necessarily need to be, a security researcher in order to take advantage of the intelligence that's there with J1. And one of the things that I love about kind of our graph rag technology is that, you can couple that with natural language search in order to then go find something semantically similar, but then traverse a graph to understand the how and the why of the relationship there. And so I'm kind of curious, in thinking about J1, maybe talk a little bit more about the journey with J1 and where you see that heading, and also maybe talk about anything that's surprised you about the journey, or anything that you're excited about going forward.
Yeah, that's a great question. So I think you mentioned natural language search as an example. I think this is a good one to talk about. So we have a capability in our platform we call Ask J1, which is effectively it's a natural language query ability over the top of a structured query language that we have natively. So it was an interesting progression for us. So our users previously and still can use what we call our J1QL query language. And that's a very powerful query language over the top of the graph substrates, where a user can actually ask questions of the graph. And those with strong J1QL skills can really find some truly interesting things in the data. But it does have a learning curve. Like anytime you ask somebody to learn some new language or similar, it's going to require an investment in time and investment effort to become proficient. So Ask J1 provided a natural language interface at the top of that allowed our users to ask questions using just natural language, and the system would handle the conversion to that underlying query syntax. So it was kind of cool. It was it not only democratized, the word you use there. It's broadened out who could use the platform from that 10% of users who are the power users. It not only allowed them to ask more complicated questions, but it also interestingly served as a little bit of a training, on-the-job training, if you think about it, for the J1QL language itself. So what we would do is we'd take the natural language and we convert it to a query string, which a user could then look at and go, oh, okay, now I understand how to join two pieces of data together. So that was all really interesting and valuable. But honestly, we pretty quickly progressed beyond using AI just as a query tool, right? It's kind of table stakes at this point. So what we're now doing is starting to use AI sitting on top of our data substrate, our graph, and provide insights to users without them having to know what questions to ask. And I think that's the critical piece. It's still fairly early in its evolution, but we're seeing some really promising results where we have AI agents that are able to reason on top of the data and surface up genuine insights that users would never have thought to ask about. And so we see a lot of examples here where there are nuggets of information and actually critical information that are just sitting in a customer's data that they don't know about. And if they'd known to ask, they would have found a piece of data that potentially could have prevented a breach. And we had a really interesting example recently where we had a scenario with an AI agent that was able to uncover a pretty significant risk by making some connections between entities in the graph. And what we had was a scenario where our AI agent was able to uncover this vulnerability where a repository's GitHub actions could assume AWS admin roles, which then gave them the ability to open PRs and ultimately list S3 buckets, which should have been private from a production account. And the interesting thing here is that nobody probably would have thought to ask that kind of a question. The other interesting thing was it was the connective nature of the entities involved, right? So you're talking about a GitHub repository, an overly permissive IAM role, GitHub actions, and an S3 repository. And it was only through the connected nature of all of those things that vulnerability would have been uncovered. And this all happened, and this is the most critical piece, without the user having to ask anything. This was something where they were able to log in and have that insight surfaced up as, did you know? I was like, oh crap, we need to go and actually get with our security team to take a closer look at this.
That's fascinating. What a crazy time to be alive, right? I mean, I remember way early in my career with managed security services. These were the types of things that we would dream about and had no way of doing. We're just about time, so we'll start to wrap it up here. We opened with Project Glasswing and AI being able to find O-Day vulnerabilities and do it at a scale that humans never have been able to do. As the chief product officer of a cybersecurity company, how are you thinking about AI as both a threat vector and as a force multiplier for defenders? And with some more emphasis on the end there, on the latter part of that question, especially as that relates to your CISO and CTO customers.
Yeah, I think that's a great ending question. So the framing that I'm using internally is a leverage multiplier. So AI is giving whoever wields it really additional leverage, so the ability to do more with the same resources. So right now, I think that leverage is available to both sides, on the offensive side and on the defensive side. And the question at this point is whether defenders are moving fast enough to actually maintain parity. So for attackers, AI is obviously, particularly with Glasswing and Mythos, is clearly dramatically lowering the cost and expertise required to find and exploit vulnerabilities. So Glasswing is that headline version of this AI finding O-Days at scale. But there are other quieter versions of AI generated phishing that's indistinguishable from legitimate communications, or AI generated code assisting in writing payloads. In general, AI helping less sophisticated actors operate at a higher level. For defenders, I think the opportunity is equally significant, but only if you have the data foundation to exploit it. So AI can help you find the needle in the haystack, that one anomalous access pattern that shows you had a compromise, or maybe that one over-permissioned account. The example I had earlier maybe is a good one. But it's only relevant if you have the haystack organized in a way AI can reason over. And I think that's a race that we're in right now. Is that can defenders build the data infrastructure that lets AI be effective faster than the adversaries can use AI to outpace human speed defense? Now, excuse me. I've actually been thinking about this quite a bit since the Glasswing announcement. And initially, I was pretty doom and gloom about this and saying, oh, the advantage has gone to the adversary. But when I started to think about it, I started realizing that we actually, coming back to the substrate and the data question, as defenders, we can have an advantage here. And that an attacker coming from the outside typically is operating without the level of insight into your environment, into all of the interconnectivity of your systems, that if you have structured your data infrastructure in such a way, you actually have an advantage, and that you understand those relationships, those entities, those chains, in ways that an attacker probably doesn't. And that gives you, if you organize and ensure that your data infrastructure is set up in such a way that you can actually have an advantage over adversaries. So I believe that the organizations that are going to win are the ones that really treat AI readiness as an infrastructure problem and not a product problem. So for me, that I think is the most interesting kind of conclusion that I would take out of Glasswing. It's initially I was maybe a lot more concerned than I am today. I do think it's a groundbreaking moment, but it's one where done right, I think can benefit the defender as much as it does the attacker.
Yeah, thanks for that. Kevin, thank you so much for joining me today. I really enjoyed learning from you. I enjoyed the conversation, and looking forward to keep the partnership going.
Yeah, Bryan, thanks for the opportunity. It's been fun.
All right. Well, thank you so much, Kevin and Bryan, for joining us today and for such a thoughtful and engaging conversation. We truly appreciate you sharing your insights on real-world perspectives on rethinking cyber risk and AI in today's rapidly evolving landscape. And thank you to everyone who joined us today as well in the audience. We hope you found the discussion valuable and walked away with new ideas and perspectives you can apply within your own organization. And have a great rest of your day.